we're going to graph some logarithmic functions now. So again, have your calculator handy so that you can compute in your calculator. A logarithmic function is a little bit different than an exponential function. We know the exponential function in general would increase as we go from left to right if that value was greater than 1. So here, yes, we are going to still have a smooth and continuous graph, but notice here the domain is that I can only plug in positive values. I can't plug in 0, only positive values. The range is all real numbers. So before that was backwards. Before the domain was all real numbers and the range was just positive values, and now it's flip-flopped. And then the graph passes through the point 1, 0 rather than the point 0, 1. So what we'll find out as we're doing this is that logarithmic functions and exponential functions are inverses, which is why it makes sense that everything is flip-flopped. So again, notice what I've done here is I am going to graph this. I'm going to turn it into exponential form, but I'm going to go ahead and plug in the f of x. I'm plugging in the y value instead of the x value. Okay, so let's take a look at why I would do that. Again, if I were going to turn this into exponential form, I would say 2 to the y equals x. So 2 to the y equals x. And that's why it makes sense to then plug in the y. So now I'm saying 2 to the negative third would be 1/8, or 0.125. 2 to the negative 2 would be 1/4, or 0.25. 2 to the negative 1 would be 1/2, or 0.5. 2 to the 0 would be 1, 2 to the 1, 2 to the second, and 2 to the third. And now I'm going to plot these points. So at 1/8, which is very, very close here, I'm at -3. Oops, sorry, positive 1/8. Man, I don't know what I'm doing. I'm at -3, forget about that one. At 1/4, which is right here, I'm at -2. At 1/2, I'm at -1. At 1, I'm at 0. At 2, I'm at 1. At 4, I'm at 2. And at 8, I'm at 3. So notice, again, this would just be decreasing here and looks somewhat like that. So it's increasing very rapidly and then it's evening out. Here now is a base of 1/2. So again, if I were turning this into exponential form, it would be 1/2 to the y equals x. Again, we're just going to plug in those f of x values. We're plugging in the y values essentially. So this is 1/2 to the negative third. So 1/2 to the negative would now flip it over to make it 2. So I've got 2 to the third, which is 8. 1/2 to the negative 2 would be 2 to the positive 2, which is 4. 1/2 to the negative 1 would be 2. 1/2 to the 0 is 1. This, of course, would be 1/2, and then 1/4, and then 1/8. So 8, comma, -3. 4, comma, -2. 2, comma, -1. 1, comma, 0. 1/2, comma 1, 1/4, comma 2, 1/8, comma 3, and we can see that now this is going to be that decreasing function, so it's basically been flip-flopped a little bit, and it's going to look something like this. So that is our other logarithmic function when our base is between 0 and 1, decreasing. Here's one for you to try on your own, so give it a shot, then press play to check your work. Again, here I would make this 3 to the y equals x, which is why we're plugging in the y values. 3 to the negative 3 would be 1/27, which is a very small number. 3 to the negative 2 would be 1/9. 3 to the negative 1 is 1/3. 3 to the 0 is 1. And then 3. And then 9 and 27. So let's see what this graph looks like. 1/27 is super stinking close here, and that's at -3. 1/9 also really stinking close, and that's at -2. And then 1/3 is at -1. 1 is at 0. 3 is at 1. 9 is at 2. And that one's way too far. So my graph is going to look like this. Again, it should be on the right side of the axis. It's going to look something like that, and it's going to even out in this direction.